Pleasure, everybody. My name is Nestor, and I am part of the Module Federation core team. I developed this thing that many people know as micro frontends, and that's pretty much my every day-to-day. And today, I want to talk about something interesting, but for me, in order to explain what all this AI jazz is, I need to take you on a little journey with me for you to understand where do we come from, why we built what we built, and where are we headed. So, of course, this all begins with a little story. Sometimes we have ideas as developers, as managers, as creators, and most of the time these ideas comes when we are vibing, essentially. But often when we are on our work environment, these ideas come to us in teams. And there is a subtle difference on this because you cannot just implement a way when you depend on your colleagues and your coworkers. And I consider myself to be lucky because most of my customers and the people that I work with want me to ship features constantly. They want new things, they want new shiny things. But at the same time, I'm also a little bit unfortunate because I tend to break things very often, as you can clearly see here. And, you know, there is this subtle conversation that I need to have with most of the big customers that we have, which is that you are slow because you are large. You are slow because you depend on processes within your organization that slow you down, understandably. But at the end of the day, what you really want deep down is to just have the ability to move faster, just have the ability to ship new features and test those with your customer base more often than not. But the big problem that we've been facing pretty much for the last arguably 20 years now is that most of the things that we develop, arguably, are something like this. Pretty much all legacy software, and I know legacy is too much of a buzzword these days, is nothing but a monolith. You cannot split that down easily to test new things or to just decide to modernize one specific thing without affecting everybody else. And backends, at some point, or APIs, went through a change around 2005, 2006, that tried to modernize this. And I guess you guys probably guess where I'm going with this, which is this thing, microservices. So somebody thought at some point that if we split our applications into very specific domains, vertical domains, or even horizontal in some cases, depending on how you look at it, you would be able to iterate faster and be able to test more features more often than not. And the very first known iteration of this was a thing named Docker that probably most of us are very familiar with these days. And everyone thought that this would be containerization would be pretty much the solution, and pretty much everyone will be happy, everyone will be happy finally with how this works. And that lasted for about 5 minutes until you realize the complexity that comes with this. And time later, somebody else appeared and said, okay, how about we add orchestration on top of this? And then, of course, Kubernetes was born and said, sure, this time, surely, everything will be fixed with this. There will be no more complexities. And my team of maybe 10, 15 people will be able to own one piece of my infrastructure entirely, and I will be able to test without any dependencies on anybody else. And that also lasted for about 5 minutes. And said, yeah, because the ecosystem around Kubernetes, this is an old picture, by the way, it is so vast, and there is so many ways of doing exactly the same thing. There is orchestration around that. It is service discovery around that, service meshes, network meshes, that now you needed one specific team within your organization to have like all the knowledge within the networking layer, the orchestration layer, and all of that, the CI/CD pipeline. that everything become a little bit more complicated than we thought at the very beginning. And frontends went through something similar at some point. One way that we can describe micro frontends is with a picture like this. As you can see here, we have microservices components where you have different verticals for each one of the APIs that you might be using. But then you have one essential monolith that you can be clearly seeing there. It's like, okay, let's split those up as well into verticals so everyone can be able to deploy their UIs independently without having to affect the rest of the team. And the first iteration of this, the very, very, very first iteration of this was iframes. I think everybody have worked with iframes at some point, and I'm sorry for you, because I know how painful it is to understand how they behave with each other, especially if you begin coupling them together, one on top of the other. These days, things are getting slightly better. I would like to know something out of pure curiosity, and this is not on my slides. How many of you here have worked with the Shadow DOM? Oh, that's interesting. Okay, a couple of hands back there. Nice. So that's another isolation layer that the browser have nowadays that make working with some iframes a little bit easier. But again, we are talking about 10 years ago, roughly. This was not a thing back then, or if it was, it wasn't as commonly used as it is today, which it really isn't. But and well, this lead to this graph. I hope you've seen this before. If you don't, I think this is outdated today. This is pretty much a graph of arguably most of the front-end ecosystem today and how it relates to each other. This is pretty much most, if not all, of the tools up there. Probably some of the logos are now outdated. I know the Vite ones are they related to the Vite ecosystem and Void Zero team, which I think somebody is around here on the Void Zero team. But this essentially is what I like to call the resume-driven development, which at the end of the day, you end up naming all of these buzzwords around technologies that you use, and you need to understand in the front-end ecosystem how these relate to each other. And I don't know if I am alone on this one, but I feel a little bit like this when I look into that graph, which, I enjoy what I work with, but at the same time, I feel bad having to let people know that they have to understand the previous one in order to kind of grasp the entire ecosystem that you have to work with. And, at some point, when all of those things are so vast and you have too many technologies to work with and specific teams in big organizations, of course, they may want to try different technology sets without having to affect between each other. We need a central layer in order to share the context between them without having to affect each other. One of these things is module federation. In essence, and I think it's the best way to describe it, module federation is Docker for the frontend. And that is probably the simplest explanation that I can give you guys in order to understand it. You essentially compartmentalize one application. Well, this is starting web, whatever. Compartmentalize one application. I am missing a slide over there. And you can distribute this application being consumed by a different one. So this started on Webpack by Sokram Tobias, which now works at Vercel, if I recall correctly, building TurboPack. And if you search for most resources online, you are most likely going to find out that most people talk about module federation Webpack 5, but that is not the case anymore. In fact, it hasn't been the case for the past 2.5 years or so. Module federation today is completely agnostic. It works on pretty much everywhere, including without a bundler, meaning that if you were doing something like lit components, or if you were doing something like, and to remember the other framework that is bundleless, Remix, sorry, you can use module federation runtime without a bundler. But of course, most of us, I believe, require at the end of the day Vite or Webpack, or maybe some of you RSpack, and I will love you if you do. And how many people use it, right? Because most people think that module federation is a niche use case or a niche library. So this is a picture I took yesterday. Today we sit at around 9 million downloads a week. And just to illustrate a little bit of who uses module federation that we know of, is this beautiful picture right here that we managed to gather I think this is updated today. I think this is from a year and a half ago. But all of these companies have some sort of flavor of federation within their stack in one of their verticals at some point. And the main reason why they need this is because they need to empower their teams to be able to ship faster without having to be blocked by anybody. And of course, if you own the domain, everything makes a lot easier. And our first iteration of trying to make life easier for people using Medusa, module federation at scale was named Medusa. So Medusa was born around 3 years ago, plus or minus. And it was built by the core team of Module Federation, Zach Jackson and Zach Chappell and other people. And the whole idea was simply that we are not going to delve down into how you like to deploy your microfrontends or your applications, but rather we are going to provide you with a way to make that predictable. So you are just going to make an observability platform around the library itself, and we are going to give you information such as which customers are pulling which version, which customers are struggling with at the time of loading a website, how are people resolving their different dependencies across the entire application as if it were a monolith. Are you pulling a different React version that you shouldn't be pulling in one of your leaves instead of the trunk? And things like that. But there was a big problem with this, which was that we ran Medusa for around a year, more or less, and we realized that even though Medusa was powerful enough and gave interesting features to some of these people using module federation scale, it really only made observability simple, and that was not the problem. That is not what people needed help with. If you think about it, when you deploy one front-end application standalone, you deal with one piece of infrastructure, and that makes simple sense, right? The moment you begin splitting this, such as when you begin splitting a monolith into microservices, you need to have different pipelines, and you need to have different environments for each one of these federated applications. So each piece began having its own complexity of being deployed, and later on, more importantly, being composed. So everything is consumed as a monolith application by a browser, so you need to decide which version of which piece do you want at any given time. And nothing have really changed in the last couple of years of how we deploy. Ages ago, when I wasn't a developer because I'm too young, people used to FTP to deploy their applications. Nowadays, we use CI/CD pipelines to push to S3 buckets. But the same idea is the same today. We are just pushing artifacts into a storage of some sort. And there is one more important question about this, which is that, as I said, if you are trying to compose an application, what do you do when something breaks? What do you do when you need to do this? The simple fact of you rolling back now is a quest of finding out, okay, which of my microfrontends breaks the app? Is it the first one? Is it the last one? Is it one in the middle? And once I know where the issue is, if I roll back that one, is the composition still workable? Are there any dependencies on that version that I need to roll back that now makes it so I need to roll back all the other pieces? Because of this problem, and after careful consideration of my team, we decided to rerun ourselves. So what was born afterwards is what today is Zephyr Cloud. And Zephyr Cloud is, in my humble opinion, an unfortunate name because we are not a cloud per se. What we are is an orchestration platform. We do not deploy your artifacts into a cloud that we own. What we decided to do, because that's what most enterprises require, is that we decided to be a middleman and just a deployment process within your with your software development lifecycle. So the simple thing that we do is that once you decide to adopt us, we bring compute into your cloud account, whatever that is, it being Vercel, it being AWS, Azure, maybe some of you here even deploy on-premise. We don't really care. We are just a way to upload things. And the later thing that we do, which is where our value resides, is that we make this orchestration easier for you. And you, of course, own the total control of it. This is basically how we understand Zephyr. Every single time that you build your application with whatever bundler you're using, we are going to generate one of these URLs. Here is one example URL from my colleague, Shane, sitting somewhere here. And essentially, we understand the application in these different levels. Every person gets their own URL, so every person in the organization. Each one has its own number of builds, so it is incremental. Every single time that you build, whenever you are building, it being locally or it being on CI/CD or pretty much whenever you build, that counter is going to increase by 1. There is projects, there is applications, and there is organizations. I think that's very standard on any cloud platform. And all of these versions that I'm talking about is just one compilation. It's just the bundler outputting assets together with a manifest file that says what that version contains. And all of those are always live. So this is how it looks like when you build. This is a Vite application, if I recall correctly. Yeah. And essentially, every time that you build, we hook into the bundle process because we know how this thing works. We wait for the bundle to do something that is called a seal, which is when all the assets are compiled and the bundle is about to close. We grab those outputs and we upload them directly to whichever cloud you're using without having to be an intermediary whatsoever. That comes afterwards when you want to compose your application. And we give you back a URL for the sake of sharing. And at some point, and here's when I'm switching back to the real conversation, this is being used by multiple enterprises today. But with all of the AI talk going on, most of our customers begin asking us a weird question, which is all of this orchestration thing that you do, that you are very good at doing because of the inherent ways of how module federation works. Can you apply this to agents? Like, can you apply this to AI somehow? And I think as a pretty understandable response from us, we went something like this and said, well, I guess. And we decided to do a quest about, okay, let's talk to our friends, which we know pretty much the entire JavaScript community. What are they doing? And how are they doing things? We began talking with the people from OpenCode. We began talking with people like Tanner Linsley and all of these people that are heavy into AI today. And at some point in our research, we found out something that I think nobody really noticed, which was an article published by CERN early past year, I believe, which was a simple article talking about how at CERN they use MQTT, which is an IoT protocol primarily, to orchestrate AI agents to investigate some of their papers. And we decided to talk to them directly. And we kind of got into some conversations how they were applying this specifically for research across different domains within their organization. And what we ended up with the kind of thinking was that, oh, we want to fix a problem in a large organization that pretty much every large organization has. They are pretty much dysfunctional to some extent. If you go to any organization today and you see between the different layers of management and engineering, you can clearly see that the bigger the organization is, the bigger a disconnection is between the product, management, design, marketing, and engineering is. And we went to the quest and say, cool, let's build a tool around this. But what we needed to do differently is that this couldn't be another engineering tool. This had to be something completely different. It had to take everyone into the same workflow together, and we need to make everyone comfortable while using it. So we kind of built kind of like a suite of tools, and this is the way that I like to disclaim it, which is like this. This is the product that we are kind of presenting. It is a weird mix, I have to say, between Slack, that I think everybody knows here, VS Code, a browser like Chrome, and module federation baked into it. And what this allows you is to make a composable super app. If you guys don't know what a super app is, this is a concept that in the West is not that famous, but in China and Asia in general, it is massive, where applications such as WeChat, for instance, are capable of embedding different other applications within the same one that are by third parties. So in the same application, you could be using different functionalities without having to force the main one into an ecosystem that they don't control. And the important bit is that it had to be catered to the flows of an organization. So if designers worked in a certain way, they have to be able to continue to work in that certain way. If marketing did another thing, so they should. And the important bit is that everyone should work in a unified platform. So these are some of the screenshots of this thing. I couldn't take more than what I'm about to show today for the sake of keeping it lean. But you have one chat app that looks like Slack, where you can talk to the different agents that we have within the platform. Here you can see, for example, one talking to Figma. If you are QA, you can also ask different agents in different chats to go and test websites. This is a desktop application, by the way, I didn't mention that. And one important bit component that we had is that previously with Zephyr, everything that we did was open source, except for the obvious platform side. So we also wanted to bring the community into this. So what we decided to center the application around is giving back to OSS and to open source. So the way you build agents into this is that there is like a marketplace built in that you essentially publish agents and specialists to. And if you are an organization such as React, to put an example, and you publish one specialist into the marketplace, you are capable of linking your Stripe back into the platform. And if people use your public agent, we are going to be back to your organization based on the amount that people use it. So that is kind of like the way that we want to give back to OSS by catering agents that people can use. And for instance, the last bit is that if you are an organization that requires one specific type of application to be built, maybe super specific to your use case, for instance, we have people that do alcohol manufacturing that have like very specific compliance mechanisms. So they need certain processes to be within their application that they use. Because everything is federated within it, you can build one application, publish it to your private cloud, and have the client be able to consume that application and be exposed to the organization that is using within your private workspace. So yeah, this is the whole pitch. This is what we are building and what I think is going to be the future. This is today about to be open. So if any of you are interested in trying it out, when we release it on beta, it's going to be open for everybody. So anybody can try it. I encourage you to scan this QR code and give it a go. And yeah, that's pretty much everything for me. Thank you very much.